Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're starting chapter 9 and we're talking about square roots, guys. And in your book, you don't have a section on square roots, but I am a firm believer in teaching properly. And I want to make sure that you know every aspect of radicals in general. And the reason why I want to talk about square roots is because this symbol right here, guys, okay, anytime that they see any sort of radical, people call it a square root. And that's a misconception, okay? That is called a radical. And we're going to talk about the names for that properly now, but it is a radical. Whenever you see a radical symbol and there's nothing up here in the left corner, that's called an index. We'll see that now in a second. Whenever that's blank, there's an invisible 2 there. So that's a square root, okay? Now, how does square roots work? What's going on here? Well, we know that 5 squared is what? Because it's 5 times 5, right? So that means we can reverse it and say that the square root of 25 is 5. 5 is the square root of 25, okay? A power of 2 and a square root are exact inverses of each other. They're opposites. A square root cancels out a power of 2. A power of 2 cancels out a square root. If I have 6 squared, that's 6 times 6 is 36. So that means that 6 is a square root of 36. If I have 12 squared, that means 12 times 12, that's 144. So that means that 12 is a square root of 144. So when we're looking at this, the pattern you should be seeing, guys, is that, hey, wait a second. A square root of a number is a value, okay, that you multiply times itself, and that gives you that value. That's what a square root is. When you look at the square root of 25 again, for example, you got to look at this as, okay, what number times itself gives me 25? And that would be, in this case, a 5. So 5 is the square root. So a square root is asking the reader to analyze the number inside of there. And it's asking the reader, hey, reader, what number times itself equals whatever's inside of here? That's what a square root is. It does not work the same for all radicals. It's different. It's the same, but a little bit different. We'll go over it now. So, square root, oh yeah. All right, square roots have 2 real root answers, okay? Please pay attention to this because this can get complicated. The positive root is the principal square root or principal nth root. And its symbol is a radical symbol with an n in it, positive. The negative root is the opposite, okay? Or the negative radical of it. When you have a square root, you have 2 possibilities. You have a plus or a minus. We'll go back to the one we've been working on. If you have the square root of 25, okay? Technically speaking, when I have a square root of 25 like this just is 5. If I tell you, give me the negative square root of 25, I want the negative root because negative 5 times negative 5 is 25. And then if I give you plus or minus square root of 25, then I want both the plus or minus roots of that 25. The inside number here can never be a negative when you have a square root. So you may say, but why do you have a plus or minus 5? Because remember what they're asking. What number times itself gives me the inside part of that? So 5 times 5 can give me 25, and negative 5 times negative 5 can also give me 25. Yes, sir. Thank you for your patience. Yes, an nth root would be, we're going to talk about that now. We're going to talk about what the index is now. Yes, sir. No, they just want you to give them, in this particular case, the negative root. They want the negative root. Here they want both roots. Here they just want the positive root. Okay? Now, Let's talk about radicals in general because vocabulary is super important. All right? And the deeper and deeper we get into algebra now, these vocabulary words are either going to help you or hunt you later. So please let them help you. This little guy right here, guys, this is called the index. Okay? When you have no index, it's 2, it's a square root. When it's invisible, it's a 2. There's an invisible 2. There's nothing there, it's a 2. It's not 0, it's never 0. If there's no index, it's a 2. Okay? This symbol right here, that is not called a square root symbol. So please, let's eliminate that from our vocabularies. That is called a radical sign. If you have a radical with an index of 2, that's a square root. If you have a radical with an index of 3, that's a cubed root. If you have a radical with an index of 27, that's a 27th root. Okay, but they're not square roots, they're radical symbols. They get their special names based on their index. Okay? And then the number inside of the radical sign, that's called the radicand. So you got to know your vocabulary, guys, because we're going to be working with vocabulary a lot here. Radical symbol, radical sign is the actual radical symbol. The index is the little number to the left of the radical symbol. And the value inside of the radical symbol is called the radicand. Again, if there is no index, it is 2, okay? Now, we have some square root properties. Number 1, every positive real number has 2 square roots, one positive and one negative, period. But look at what this says. Every positive real number. It may not be a perfect square, but you're going to have a positive and a negative root. Doesn't matter if it's a perfect square or not. The square root of 0 is 0, guys. I know that some of you may say, why did he even say that? Because some people get lost on that. And last but not least, for any real number a, where a is greater than 0, the square root of a raised to the second power equals a. When you have a radical sign and you raise that radical sign to the second power, this guy and this guy cancel. Basically, when you are raising a radical to the same power as the index, the radicals cancel. The radicals cancel. So for example, the square root of 16 squared, well, my brothers, this power of 2 is going to cancel out that square root, and guess what? That's 16, y'all. Period. If I have the square root of 7.5 and I'm squaring that, y'all, that cancels with the power. And my answer is going to be 7.5. So when you have a square root, or any radical for that matter, and you raise it to the same power as the index, brothers, they radicals cancel. Does that make sense, gentlemen? Any questions so far before we move on? We got plenty of time. Okay, thank you, gentlemen. Now, simplifying square root radicals is very easy if you know your perfect squares. This is a big if. Remember that a perfect square is a product that came from multiplying a number or variable times itself. For example, the square root of 25 is 5 because 5 times 5, or 5 squared, equals 25. Okay? Now, in this particular case here, guys, we have to learn all of these. That means we really have to memorize them all. That means we really have to learn them all. It is going to make your life easy. Give me 1 second, please. Okay, sorry about that. So please, guys, do yourselves a favor and memorize these. I promise you, that it's going to help you out later. I promise you. Okay, now, in order to evaluate a square root, simply ask yourself what number times itself equals the radicand. Because again, guys, what's going on with square roots here is there's an invisible 2 here, okay? And what this is telling the reader is, hey, reader, what number times itself equals this 49? Well, if you know these, the answer is 7 right quick. But if you don't, guys, and you have to break things down, I want to show you how to do it. If you break this down, that's a 7 times a 7, right? Now, you know you have an invisible index of a 2. That means that every 2 of the same number or variable comes out as one of those variables. So if I have a 7 and a 7, it comes out as a 7 and I'm done. Now, 1.44, you may say, whoa, that's tough. No, it's not. Think about it like this. This is 12 times 12, right? Is 144, right? But if I have 2 decimal places, how did I get 2 decimal places? 1.2 and 1.2. Thank you. So I have a 1.2 and a 1.2. So I had 2 of the same value. So it comes out as 1 of that value. Every set of 2 numbers or variables comes out as 1 of those variables or numbers. Square root of 436 is 2/6, which then will equal 1/3. Yes, sir. So, anyways, D, square root of 4/3 raised to the second power. What is that going to equal? 4.3, because that square root and that power cancel out. We got 4.3. Perfect. Now, what do I say? -5 times the square root of 81. What's the square root of 81? So I've got -5 times 9, which is -45. Okay? That's the way it goes. Now, I want you to see something. With 81, of course, it's so much easier if you just know the number. But let's just say you don't. 81 can be broken down into 3 times 27. 27 can be broken down into 3 times 9. 9 can be broken down into 3 times 3. Now remember what I said, guys. This is a square root, right? Because there's no index. It's invisible. So I have this -5. Now pay attention. Every pair of values comes out as 1 of that value. So a 3 and a 3 comes out as a 3. A 3 and a 3 comes out as a 3. And that's why we have -45. So of course it's way better, way quicker to just know your square roots. Like, I mean, you're going to fly on this chapter if you know your square roots. If you don't, it's going to take you time, but you can do it by breaking it down. Okay? Here, square root of 4 is 2 plus 8, so that's 10. Nice and easy. Square root of 9 plus 16, this is like order of operations. This is square root of 25, which equals 5. I got the square root of 64 minus 4 times 7 times 1, so that's 64 minus 28. And that gives me square root of 36, which equals 6. Great. Why am I not putting plus or minus on all of these? Because I'm not asking for a plus or minus. They're asking for the positive root. But if I had said, hey, dude or dudette, I want plus or minus the value of this, then I need both roots. Does that make sense, guys? Okay. All right. Now, how do we determine if a square root is rational, irrational, or not a real number? Very important stuff here. Rational square roots are perfect squares, guys. Perfect squares. Such as square root of 144. Such as, oh, do I have another one? Yeah, square root of 9. We knew that from our definition of rational numbers back in the beginning of the year. If you recall, we said rational numbers are numbers that can be written in fraction form A over B, and they include whole numbers, natural numbers, integers, fractions, mixed numbers, perfect squares, terminating and repeating decimals. An irrational square root, guys, I'm sure you guessed it already, is a non-perfect square, such as square root of 30 or square root of 42. So rational square roots are perfect squares. They have a perfect square. Non-perfect squares are irrational square roots. And the square root of a negative real number is not a real number at all. It's actually called a complex and or imaginary number, and we will get there. But the square root of -4, the square root of -15, that is not a real number. You can do this. It's going to be 2i. The answer will be 2i. But we're not there yet. I'll get there when we get there. That's in the complex number system. We're good? Okay. Now, when a radicand is not perfect, y'all, you can write a decimal approximation of the radical. You can simplify the radical using properties of radicals, coming soon. Or you can use a calculator to find the decimal value if allowed. Okay? First of all, let me show you how to do this with decimal approximation because it's pretty awesome, it's pretty useful, and I train my kids to use this on the SAT just to get an idea of where the answer could be. So I want to find the square root of 17. Okay. So I have a square root of 17. Well, I have no idea what that is because that's not a perfect square. However, I do know that there's a perfect square less than that. What is the first perfect square less than square root of 17? Yeah, so square root of 17 is greater than the square root of 16. And what is the first largest square root after square root of 17? You darn right. Thank you, my brothers. So wouldn't that logically tell you guys that square root of 17 is between 4 and 5? Does that make sense? So is square root of 17 closer to 16 or closer to 25? So would that logically tell you guys, okay, this answer is going to be closer to the 4 than it is going to be to the 5? Does that make sense? So now we just guess and check, guys. And yes, I'm using a calculator just for speed. But you go 4.1 times 4.1. That's going to give you 16.81. Pretty close. But let's see if 4.2 is closer. 4.2 times 4.2. That's going to give you 17.64. Now it's up to you. Who's closer? 16.81. So this is roughly, approximately 4.1. If I were to actually get this value, the exact one, it's 4.12310566626. But that's pretty good. Again, for doing it in your head, that's a pretty darn quick and easy and good way to do this, okay? So please be careful with that. Now, determine whether each of the following is a rational or irrational or not a real number. So, square root of 70. Is that a perfect square, guys? So this would be irrational. Sorry about that. I don't know why it keeps doing that, guys. Irrational. Okay, how about B? Is that rational, irrational, or not real? It's not real. It's not a real number. And 225. That's rational. What's the square root of 225? 15. Yes, sir. It would be 10i. Thank you for B. Yes, sir. Because that's the complex. You're absolutely right. Thank you, my brother. Very well done. And now, okay, I wrote this out, guys. I didn't want you to write it out. I need you to really focus. I really need you to pay attention. Because right now, I can make it all easy, or we can start in the confusion train. It's up to you. So please, I got plenty of time. Ask questions, please. Sometimes you have to simplify variables in the square root, which are really, really easy, okay? All you have to do is divide the exponent of the variable. So you're going to have some sort of variable in a radical. Okay? You're going to find the exponent of that variable. And you're going to take that variable and you're going to divide it by the index of the given radical. Okay? Which in the case of a square root would be 2. The whole number comes out of the square as the exponent of the variable. And all remainders stay inside of the radical as the exponent of the radicand variable. I'm going to explain this. Please note, please be aware that when you have the square root of a squared, it must come out as an absolute value of a. Now, give me a second, because for some of you, I may have just confused you. We said a few minutes ago that if I had the square root of a squared, it equaled a straight up. And that's right, that's accurate. There's nothing wrong with that. But now, Moro, now you're telling me that when I have the square root of a squared, it comes out as an absolute value. Okay, now you're confusing me, buddy. Why? Why did I do that, Bubble? Wow, I couldn't have said it better myself. I'm so proud of you, kid. Great job. Great job. What my boy just said was this, and it's brilliant. I am not allowed to have negatives inside of square roots. Do I have any guarantee that this a that I pulled out is a positive number? No, right? Think about it, guys. Let's say that a was negative. What's a negative times a negative? A positive. So this has to come out as an absolute value of a. Has to. Has to. And I got one little extra thing for you. Whenever you pull out an odd exponent from an even index, comma, it must be an absolute value. Has to be. So there are two huge different conceptual things here. Here I'm taking the square root of a number. I don't care what the number is, positive or negative. I don't care. If I square it, blagada, cancels. But when I have the square root of something squared, yes, they're still going to cancel, but that's because a squared is an a times an a. So I took out something from the radical. And whenever I take out an odd exponent from an even root, it must come out an absolute value. Last thing, since square roots cannot have negative radicands, all real numbers and odd exponent variables or polynomials must come out as an absolute value. Just another reminder of that. Now, the best way to learn this is to practice. So, let's get to it. I have a square root of 15 squared. Cool, cool, awesome. 15 squared is 225, right? What's square root of 15? Of 225 is 15. And it's an absolute value, which already equals just 15. I have a square root of x to the 7th. Okay, here's where the magic starts. What is my index of a square root, y'all? 2. Now, pay attention, brothers. How many times can 2 go into 7 evenly, guys? 3. So think about this. Let me know if this makes sense to you. Does that not mean that I took out 3 sets of 2x's? You see what I'm saying? I'm taking out 3 sets of 2x's because every 2x's comes out as 1, correct? So I'm taking out 3 sets of 2x's and I have a square root of 1x left, but this has to be an absolute value. Because I took an odd out of an even. Why does it matter, Moro? Well, if x equaled -1, guys, What's negative 1 to the third power? Negative 1. Can I ever have a square root equal a negative? No, it's impossible. It cannot happen. But Moro, square root of 25, you said was plus or minus 5. Yes, it is. But that doesn't mean that the base inside was a negative 5. Is this making sense, guys? I want to make sure I do a good job here and you guys are clear with this. Okay. Next, I have a square root of 8 of x to the 8th. How many times does that invisible 2 here, that index, go into 8? So this equals x to the 4th power. Why would that not be in an absolute value? Because it's even. Not just because it's even, but let's think about this scenario again. Let's say that x was negative 1. What's negative 1 to the 4th power, guys? Positive 1. So we're in the clear. We just got to make sure that when we pull out odd exponents from even radicals, that they come out in an absolute value because it has to be positive. Okay, how about this bad boy? Square root of 3x minus 1 squared. This guy and this guy, they cancel, right? So it comes out as 1, right? I'm taking out a 3x minus 1 to the first power, correct? So it's got to be an absolute value. It's got to be. And then here, this is a great one. This is the square root of a negative 15 squared. Most people are going to do this. Placata, placata. Oh, it equals negative 15. That is absolutely wrong. It is absolutely wrong. If you think about this, guys, this here is the square root of negative 15 times a negative 15, which is positive 225, which equals 15. I just followed the order of operations. Now, you don't have to do that long way at all. All you got to remember is, hey, I have a negative, I'm raising it to a positive power. Whenever I have a negative raised to an even power, it's going to come out positive. So this will cancel, but it comes out as a positive 15. Please be careful, because if I give you this, what would the answer to that be? In this case, it'd be negative 15. Why is this different than this? Thank you. Because this guy is to everything, guys. When I raise a power to a power, don't I multiply the exponents? We're going to learn in a few lessons that this square root is really an exponent of 1/2. 1/2 raised to the second power is 1. So it cancels, and the inside part comes out easily. But here, in this one, I'm taking something out of the radical. When I take it out of the radical, I have to put into absolute value if I took an odd out of an even. Do you see the difference there, brothers? Okay. Now here, what is that, Moro? Well, factor it. That's x plus 3 squared. How did you do that? Well, that's a perfect square. That's x. That's a perfect square. That's 3. 3 times 2 times x is 6. It works. There's a plus squared. But now, fuagada. So I pulled out an x plus 1 to the first power. So I must put it in absolute value. Sir.
Going back to B.
Yes, sir. B. Yes, sir. B.
Execute absolute value with the radical x.
Yes, sir.
Couldn't you just do x to the 3.5 as well?
We're not there yet. But we're not there yet. We could do 3.5, but that's because you knew that it was x to the 3 times x to the 1/2. But I don't know that yet. All right, we're not there yet. Let's walk before we run. But yes, you're absolutely right. But that would be a tricky one, though. Actually, no. In that case, to be honest with you, to be technically accurate, it would be x to the 1 to the 3rd times x to the 1/2. Because you need that absolute value. But thank you, sir. But yes, completely right. We're just not there yet. Thank you, boss. Any other questions on this, guys? Questions, comments, concerns, problems, issues? Yes, sir. Come again, my brother? Why would it be 3x plus 1? No, not at all. Let's take a look at it again. Thank you for your honesty. Okay. This breaks down into a 3x minus 1 and a 3x minus 1. A 3x minus 1 and another 3x minus 1. That means I had 2 of the same. Comes out as a 3x minus 1. And this just happens to be to the first power. So I have to put an absolute value. No, I do not change the middle sign of that 1, though. Great question. Thank you. We're good? Fantastic. Thank you so very much. Have a wonderful day. God bless you, and I hope you learned a lot. Bye-bye, guys.